Hey all, good morning and very happy morning to everyone. So today what we are going to discuss in this video means the questions which were asked in the previous year questions, the most important frequently asked questions in the chapter units and measurement. Let me zoom in and our first chapter it's units and measurement. Almost two questions were asking from this chapter every year, definite two questions. The first question, this is the complete analysis based on 2023 and 2022 question paper and based on the Vernier caliper question, one type of question. The type of question they were asked is about the mean diameter. How do we find the average? How many values and divided by that number? That's it. And second, the foremost thing is about we have to discuss about the dimensions. Dimensions is the most important part, so we will discuss about dimensions later in this video. And next topic is errors in measurement. These four errors, what is these errors? So these are the topics. And next is percentage error. How do we percentage, how do you identify a percentage? Okay. And also based on the formulas, this is the density, mass by volume. Volume is pi r square L. These are the values. And how do you write in such a manner? This is the value of delta and this is the value of normal. So delta rho by rho is equal to delta m. The formula I'm writing here like this. So this is the method to identify the percentage errors. And concept of error is also the important, that is percentage error like this. And the one question is the unit of plane angle and solid angle. Plane angle has a unit radian, solid angle has a unit steradian, but both are dimensionless, they don't have any dimensions. This is the important question because they have a similar upper has length, down here has length, so both are get cancelled, so zero dimension, no dimension is there. And about significant figures is an important question, the concept they were asking every year. And to identify the area, length into breadth, they same this formula wise, so this manner it's important. So let me introduce you some dimensions. Wait, these are the dimensional formula. Area has let me zoom this dimensional formula. I'll explain you so up to certain things, and about that I'll share you the PDF. You'll note in that it's a easy manner. Area is length into breadth. And volume is length into breadth into height. Length we can represent it as L, breadth also we can represent it by capital L. Okay va? So we can write it as L into L, that is L square, L into L into L, that is L cube. Density, actually for mass we are going to represent capital M. For length, height, breadth, these are all quantities, we are going to represent L. And for time we are going to represent T. This is the matter, these are the units and dimensions. And let me increase my pen length. And density, the formula of density, what we know as density is equal to mass by volume. Mass in the sense capital M, so volume in the sense length into breadth into height, that is L cube. So mass by volume divide la irukadhu mala pochuna it will come in minus, so L minus 3. And I think this is 2 over. Okay. And next, the formula is velocity. This is the dimension is the most frequently asked question in every year. I'll tell you about 10 values. You'll read other values. Okay. So okay. And acceleration is velocity by time. Speed is distance by time. Distance in the sense which can be represented by L, time in the sense T. So divide la irukadhu multiply ku mala vandaduna it will come in inverse. So this is a simple. Momentum is mass into velocity. P is equal to mv. This is the formula. Force is mass into acceleration. Work is, remember all these formulas which will help you later in the 4 marks from this chapter. Dimensions is exactly work, force into distance. Energy is equal to amount of work. The unit for work and energy is almost the same. Power is work done by time taken. Pressure is force by area. Moment of force or torque you can represent as force into distance. And gravitational constant is, this is the one, which we can also write as F is equal to gm1 m2 divided by r square. This is the formula they were writing like this. Let me erase this. An impulse is force into time. Stress is also the unit of pressure, force by area. Strain is dimensionless, remember it. And coefficient of elasticity is stress by strain. And surface tension, force by length. So there are almost 50 plus quantities. This also I explained later in our physics papers. Last they were given some dimensions. I explained even there. Angle is a dimensionless. See, these trigonometric ratios are dimensionless. So make sure I'll share this PDF. So make sure these are simple formulas. You have to remember just the formulas and you have to write by your own. Okay. And the one more thing I say is current is which can be represented as ampere. Okay, and temperature you can also represent it as Kelvin, K. And these are the changes, and I'll share you this PDF and make sure of it to remember all these 50 to 60 dimensions. Definitely the questions may arise in this topic. Okay, let me share you the book PDF about the formulas. What you have to note. Yes. Okay, I explained you what are the dimensional quantities and what are the quantities you have to study, and what are the topics that were frequently asked from this chapter. So let me teach you the basics which were asked in this chapter. First, a physical quantity, any physical quantity which is represented by a unit. It has some international standard unit. The basic units or fundamental units. The units which are derived from the fundamental units are called derived units. There are only seven basic units. Okay, the international system of units is CGS system, that is centimeter, gram, and centimeter, gram, and second. This is CGS system. FPS, foot, pound, and second. MKS, meter, kilogram, and second. This is the system they were following throughout the world. Yes, as I explained here, this is plane angle and solid angle. The unit of plane angle is radians, and the unit of solid angle is steradian. Is zoom out, steradian. Both are dimensionless quantities. And let me show you what are these fundamental basic quantities. Length, whose name is we can represent as meter, symbol m. Mass, kilogram. Time unit is second. Electric current is ampere. Temperature you can represent as Kelvin. Amount of substance you can represent as mole. Luminous intensity you can represent as candela. These are the basic units. And let me move to the next topic that we are going to see about the significant figures. Okay, what are those significant figures? Significant figures means the figures which has some value. So what are those significant figures? Let me explain it. All the non-zero digits are significant. 1 2 3, this is the number. You can say 1 2 3 here as three significant figures. So this is the one. First, all non-zero digits, zero illada digits ellame significant. All the zeros between the two non-zero digits are a significant. A good thing. all the 1 0 0 1. These are the two zeros which are between two non-zero, correct? So here has four significant figures. And if your number is less than 1, the 0 on the right side of the decimal point but left to the first non-zero digit are not significant. Yes, the 0 after the decimal point. The example they were given, the 0 first to the decimal point but before the non-zero digit in a decimal point is not significant. Here has only four significant digits. The left side zeros are not significant. Okay, and the next concept is the terminal or trailing zero without a decimal point or significant. Here the zeros has some significant value. The trailing zero without a decimal point or not significant. What they are saying is without a decimal point they are not significant. Here is only three significant figures. The simple thing you have to remember is all non-zero digits are as significant and all zeros between two non-zero digits are as significant, and the zeros which are left to the zeros which are right to the decimal point but left to the non-zero digits are not significant, as I mentioned in the third example. And the fourth example is without a decimal point, the zeros on the right side are not significant. Trailing zeros, terminal zeros, okay, not significant. The zeros before left to the non-zero digit in a decimal point is not significant, and the zeros or the terminal zeros, last zeros, are not significant. As next is the trailing zero in a number decimal point or is significant. That is, the trailing zeros in a number with a decimal point are significant. They see here 0.06900. The 0 before 6 is not significant, as we seen in the rule number 3. But after the non-significant digit, the 0 has some value. Okay, with the decimal point or a significant, but without a decimal point or not significant, and also left to the non-zero digit or also non-significant, but right to the non-zero digit with a decimal point or a significant. These are the rules you have to remember carefully. And without any yes, they were simply given here without any decimal, the trailing zero or not significant. See, again they are stressing the point, this one here, without any decimal point, the trailing zeros are not significant. And the last point they are stressing here, for a number with a decimal point, this trailing, the last zeros are significant. This is things. And let me move to the next slide. And yes, significant figures in multiplication and division. How do we use? If we multiply the two quantities or if we divide the two quantities, the answer must be, if for example in question they were given these two values, okay, see which one has least significant number. 2.51 is the least significant number which has three significant figures, so our answer should also be in three significant figures. This is the rule for both multiplication and division, as well as addition and subtraction. And same addition and subtraction. And next is rounding off. Simple. If it is around 1.735, if it is 5 or above 5, the preceding digit is raised by 1.74, you can write. And if it is below 5, 1.734, you can write as such 1.734, you can write as such, it will left unchanged. Okay, and the next is for about the example sums. The example sums you will see later, you see later part. Yes, and some of them were explained. The uncertainty is the rules for determining. As I explained there one some no mass density delta rho by rho, so those method is also important. Okay, and here the quantities, yes, the dimension as I explained here earlier. For everything they were given. For some of the quantities they were given the dimensional formulas. Shall we derive one dimensional formula? um, shall we derive the dimensional formula for force? Okay, what is the formula for force? Mass into acceleration. How we represent mass? As capital M. How we represent acceleration? Acceleration is equal to meter per second square. This is meter. How you can represent meter? You can represent as L per second square, t power minus 2. Okay, so this you can write as L t power 2. So the dimensional formula is t power minus 2. So the dimensional formula for force is m L t power minus 2. This is the thing you have to write. Meter per second square. A simple thing. Again I'll explain you what is the formula for acceleration. Acceleration is meter per second square, so L t power minus 2. What is force? F is equal to ma. What is m? Is a mass. So this is the dimensional formula for force. So this like you have to easily calculate the dimensional formula. And same, all the questions are like this, and you have to prove the things. And the formula they were given for a length of the bob and the pendulum is t is equal to 2 pi root of L by G. This is the formula. They were derived in a systematic, in a manner, like in a derivation manner. So they were derived. T is equal to 2 pi root of L by G. So these are the things which are present in the chapter units and measurement. So make use of all these notes and make a short formula list. Make combined all these formulas which are given separately. Okay, thank you. And in next video I'll explain all these 5 basic model examples. Thank you.